let's take a look at this sphere. The Earth can be taken as a sphere because the Earth is spherical in shape. Now, when we look at this sphere here, it has some points on the surface of the sphere. These points can be taken as locations on the Earth's surface. Now, we have point B and point D that are on the sphere, and there's a straight line through them. These points B and D are the poles of the sphere. So this is the North Pole and this is the South Pole. The D is the South Pole. So the North Pole is also called the 90 degrees north, latitude 90 degrees north, and the South Pole is latitude 90 degrees south. So the line segment joining B to D is called the axis of the sphere, and it forms the diameter of the sphere. So the center is A, so from A to B is the radius of the sphere. Now we can draw a circle that goes through the poles. A circle that goes through the poles. So this circle that we drew here is called great circle. Great circle. So any circle that we draw through the poles forms a great circle. So this great circle here divides these into two equal parts, the sphere into two equal parts, two equal halves. Now, one half from the poles here to the next pole, we can call it the longitude. So when we call this longitude 0 degrees, then the other half here will be longitude 180 degrees east. Then from here to here will be longitude 180 degrees west. Now we can be asked to calculate the distance between 2 points along this longitude or meridian, or any other great circle that passes through the poles. We can be asked to find we can be asked to find the distance between these 2 points. So when we are asked to find such a distance, then we can see that that great circle has a radius that is equal to the radius of the sphere. The formula we use to find the distance along the great circle is given by, let's say, distance between any 2 points on the Earth's surface. Let's say AB. So from A to B will be given by theta over 360 degrees times 2 pi r. So we are going to use the big R in this case. So the big R here is the radius of the Earth. Now this can be taken approximately as 6,400 kilometers. That is this big area. Now the reason why it is so is that since the Earth is spherical, the distance between any 2 points, let's say A here and B over here, will form an arc. So the length of arc is given by theta over 360 degrees times 2 pi r. So now if the 2 points AB are on the same side of the equator, then the angle between them will be formed by subtracting the angle here or subtracting the angle here from the one here if they are on the same side. So if A and B are also on the same side, maybe they are all to the south, then we again have to subtract the angles. But if A is here and B is here, then we have to add the angles. So this angle plus this angle will give us the angle from A to B. So let's say we have a question like this. X and Y are 2 points on the Earth's surface with coordinates 32 degrees north, 120 degrees east, and 45 degrees south, 120 degrees east. So these are the longitudes and these are the latitudes. So we can see that one of the latitude is above the equator, whilst the other one is below the equator. So this is above the equator, this is below the equator. And we have the meridian. So if I sketch this, here, we have something like this. So 120 degrees east, 120 degrees east over here. Then we have the latitudes 32 degrees north. So if this is the equator here, then the latitude 32 degrees north will be here, and the latitude 45 degrees south over here. So point A, point X is here, and point Y is here. So we want to find this length of arc. So this angle here is 32 degrees, and this one is 45 degrees. So to find the whole angle, we need to add. So the distance between X and Y is given by, so distance from X to Y will be equal to theta. Theta is the angular distance, which is 32 degrees plus 45 degrees all over 360 times 2 pi r. So the r here is the radius of the Earth, which is big R, and that is 6,400 kilometers. So when we evaluate this, substituting the value of pi, we get 77 over 360 degrees times 2 pi r, and this will give us 8,600 kilometers to the nearest 100. When we evaluate that, that's what we'll get. So great circles are formed when we draw a circle that passes through the poles. Let's talk about another great circle. So this one, it doesn't go through the poles. It's called the equator. It is also equal to this great circle because it also divides the Earth into 2 equal parts. And the radius of this equator is the same as the radius of the Earth. So the only latitude that is a great circle is the latitude 0 degrees or the equator. Now, if we draw another circle that is parallel to this equator, it forms a small circle. So this circle at the top here is a small circle because the radius is not equal to the radius of the earth. Now, how do we calculate the radius of small circles? The radius of this small circle is from this point J to G. That is the radius of this small circle. Now we can see that A to G and A to K are radius of a great circle. Now we can pick triangle G, we can pick triangle JGA, triangle JGA to get something like this. So we have something like this. So this is the angle this small circle makes with the equator. So let's call this small angle here alpha. Now this alpha will be equal to the angle over here, alpha. So this is a small radius and this is a big radius. This is also a big radius. So the whole thing will look like this. So there's an alpha here, there's a big radius here, there's a small radius here. So you can see that cosine of alpha will be equal to adjacent, which is r over big R. So small r will be equal to big R times cos alpha. So this tells us that when we know big R and we know the angle, that is the angle from the equator to the latitude, the power of latitude, then we can find the radius of the small circle. So we can now also calculate the distance between any 2 points on the Earth's surface using the formula. So let's say distance between AB on the Earth's surface will be theta over 360 degrees times 2 pi small r, where small r is given by this relation. So let's take an example. We have a 50 degrees, we have A 50 degrees north, then 15 degrees east. And we also have B 50 degrees north and 75 degrees east. These are 2 points on the Earth's surface. Now we want to assume that the Earth is a sphere of radius 6,400 kilometers and pi is 3.142. And we are to calculate correct 3 significant figures, the distance AB measured along the parallel of latitude. So this is the parallel of latitude that is shown there. Again, we are talking about a small circle. So in this case, we need to calculate the radius. So radius will be equal to big R, which is 6,400 times the cosine of the angle that the latitude takes to the power of latitude from the equator. So that will be 50 degrees. So cos 50 degrees. And that will give us so 6,400 cos 50. That will be equal to 4113.84. So this is our radius. Now to calculate the distance AB measured along the power of latitude, that distance will be given by that distance AB will be given by theta. So now we can see that we have 15 degrees east and 75 degrees east. So just as we subtract for the great circle, if the 2 points are on the same side, the same thing that applies over here. We can see that the points A and B are all to the east. So the angular distance will be 75 minus 15. So 75 degrees minus 15 all over 360 times 2 pi. So pi is 3.142 times r. So the r is 4113.84. So this will give us 4308. 4308.56. So to three significant figures, you will get 4300 kilometers. 4310 kilometers. We are also asked to find the shortest distance between A and B. So that shortest distance is a distance that goes through the earth. So this is A and this is B. So we have the angle here to be 60 degrees. Now, the shortest distance is the length of this chord that is here. And we can find that using trigonometry. So this is half of AB, half of AB, half of AB is here. So, this line here divides the 60 degrees into two equal parts. So half of the angle there will be 30 degrees. So we have this 30 degrees, and this is half of AB. So we want to find this distance, and we know R already to be equal to 4 113.84. So the shortest distance will be given by sine 30 degrees will be equal to opposite, which is half AB over hypotenuse, which is 4113.84. So it means half of AB will be equal to 4113.84 sine 30. Sine 30 is half, so times 0.5. So multiply through by 2, that will give us AB is equal to 4113.84. So to trace significant figures, we get 4110 kilometers.